Okay, so welcome back to my new video on doing statistics with Golang package. Okay, so as you can see my screen, I'm on pkg.go.dev website. So as you can see, there's a repository on GitHub. And then as you can see, start Golang statistics package. This is how you're going to install it. I'm going to show you how to install this package. And these are some few examples you can use. Okay, so I'm going to copy this. And then as you read, it's a well-tested and comprehensive Golang statistics library package or model with no dependencies. Okay, so this is the entire library to do all your statistics. So if you want Manhattan distance, this is the func Manhattan distance and then the data points. Okay, this returns a distance and then an error. So we're going to look at some of these examples, how to find the max, and then there's an example how to find the max, the mean, the median, and things like that. So let's jump right into the IDE, and then I'm going to show you. So right now we are in the IDE. So I'm going to create a new Golang project, which I'm going to call Go Statistics. Okay. And then I'm going to remove this go.mod file. So currently we are at this directory. So I'm going to do go mod init. And then I'm going to call it go statistics. Okay. So I'm going to do go mod, we tidy up everything. And then I'm going to install the package, which is go get github.com Montana Flynn /statistics. So I'm going to install this. So as you can see, it's been added and it's of version 0.6.6. So if we open this mod file, there are some extra information in the go.sum. And then in the mod, you can see requires this package, all right? So that is all to the installation. Now, let's close all this and then create a new Go file. We're going to call it main. Once we do that, we're going to import github.com / let me see what the name was, Montana, and then start, Montana Flynn /start. So now let's just call it ST, okay? Let's rename it as ST. Then let's come into our main function and say data let's declare an array of floats, okay? Float 64. And then we pass in some value, okay? 2.1, 3.2, 4.823, 4.1, and then 5.8. Okay, so this is our data. Now we want to use the FMT, and then we're going to say, let's start with the mean. The mean, then we're going to say st.mean, and then we pass in data. Okay, so let me pass in percentage float. It's a float, so we can make it 3 decimal places. Okay, so let's do this. This also returns an error. We call it mean, and then we suppress the error. We don't want to print the error if there is one. So this is how we're going to do it. So we assign this value, the mean value, to this variable, and then we call that variable here. So let's just run this. Let's run this and see what we get. Okay, so this is supposed to percentage F, print F. So now you see the squiggly line is gone. So we run this. You see the mean is this 3.504 to 3 decimal places. So now we can check the median, and then we suppress the error, st.median, and then we pass in data. Okay. So we can replicate the same thing and say median percentage 0.3 F, and then we say median, right? So let's do for the mean. The mean, we pass in our data. We're going to copy this. And paste one more time. So this is going to be the mean, the max. Okay, so this is going to be max, st.max, and then we pass in data. Okay, so let's run this and see what you get. Okay, so all this needs a new line. So I'm going to pass in the new line. So this is the mean, the median, the minimum, and then the maximum value. So we can also check we can also do sampling, okay? So we can sample from this data. So we call it sample. I'm going to suppress the error one more time, st.sample, and then we pass in. This sample method takes an input and then takes a number and then a replacement, whether we want to replace with replacement or without replacement. So you pick sample and then you replace it back and pick another one. Or we just pull from the population without replacing it back. So whichever way, let's pass in our data. And then the number we want to pick from the population. So now, as you can see, we have 1, 2, 3, 4, 5, 6 data points, but we just want to take just 3. Are we to do replacement or without replacement? With replacement, you can pick the same number again. So we say without replacement, false. So let's now do print f, and then we say sample percentage f. Then now we can do sample, and then we can also do new line here. Okay, so let's run this. So as you can see, we've been able to pick 3 numbers from the population of 6. Let's run it again. You see, we got a new set of numbers, but I think this appeared again. You see, 2.1 appeared again. So if I say replacement is true, you see, this number is appearing twice. Okay. But let's make it false. We get the idea. We can also do correlation and then maybe standard deviations and things like that. Okay, so let's try how we can compute correlation and standard deviation. So I have this data here, which I'm going to call data 1. Okay, it also has 6 elements. So what we can do here is find correlation between these 2 data points. So I'm going to do call, and then st.correlation. And then I'm going to pass the 2 data points. So now I can print FMT correlation percentage 3f new line, and then I pass in call. So let's run this. So you can see the correlation between this data point is about 60. Let me put it into percentage form times 100. Okay, that is like 68 or 69%. Okay, so that is the correlation between these 2 data points, 68, 69%. What can we also do? Can we also do standard deviation? Let me call it STD. Standard deviation. So I'm going to pass in data, yes, data. And then I'm going to pass in FMT printf standard deviation when 3f, 3 decimal places is a float, STD. Okay. So let's run this. So you can see, I think let's make it a new line. See, the standard deviation is 1.618. Okay. What else can we do? Yeah, so I think those are some of the basic statistics. Let me see if I can explore more. ST, mean, max, sample, median, mean, standard deviation, correlation. Or you can also do regression. You can also find a sigmoid of a series, autocorrelation, Chebyshev distance. You can also find a covariance between two data points. So let's do the covariance. So I'm going to pass data and then data one. I'm going to call this CV, suppress the error. I'm going to print covariance %.3f new line, and then I'm going to call it CV. So if we run this, see the covariance is around 42, okay? 42. Let's see what else we can explore. You also find the entropy, Euclidean distance, Euclidean distance. I haven't tried this before, but let me see if it's going to accept data and data one. Okay, so let's see. EC or ED, let me call it ED. Let's suppress the error. FMT Euclidean distance. ED. All right, so let's run this. Okay, so let's do new line. All right, so you can see the Euclidean distance is 85. So if you do the Euclidean distance between these two data points, you're going to get 85. Wow, this is very interesting. So let's do for another one. If we find another interesting metric, harmonic mean, geometric mean, linear regression, logarithm regression, Manhattan distance. So let's compare these two distance metrics. So data, and then data one. Let's see, let's call it MD. Let me just copy this. We'll call it Manhattan distance. Then I'm calling it MD. Okay. So as you can see, the Euclidean is saying 85, and then the Manhattan is saying what, 103. Okay. Let's look for one more distance metric. if there is one, but I think that is all I want to do in this video. So let's see. Minkowski, okay. So let's try Minkowski distance. That takes three argument data, one, and then a lambda. Not sure what the lambda is, but I think the formula is out there. So let's say the lambda is 0.5. And this returns a distance and then an error. So the lambda, aka P or city blocks with lambda is equal to 1, return distance is Manhattan. And if lambda is 2, it is Euclidean. So 1 and 2, they say if it's 1, then it is Manhattan. But if it's 2, it is Euclidean. So let's experiment with these values and see. 1. So let me call it MKD. Suppress the error. Let me paste this. Minkowski. And then I'm calling it MKD. You see, when the lambda is 1, Minkowski distance is the same as what Manhattan. So let's make the lambda 2. If lambda is 2, Minkowski is the same as what? Euclidean. So this is the relationship. So this parameter is the one that determines if it's going to be Euclidean distance or Manhattan distance. So let's say the lambda is 0.5. So you can see Minkowski is 335 if lambda is 0.5. So let's take a number between 1 and 2. So let's take 1.1 or even 1.5. It's a number between 1 and 2. So let's run this. See, a number between 1 and 2. Minkowski is what? 87. So it's a number that falls between 85 and 103. So let's do another 1.2. You see, the number is, Minkowski distance is 93, so a number between 85 and 103. Yeah, so you get the idea. It's a powerful statistics package, and I hope you've learned a lot. Go out there, check out the repository on GitHub, and then try your hands on other metrics. Thanks for watching this video. I'll see you in the next one. Happy learning.